In this portion of the lab, we're going to play around with our ability to unmix the heavy and light end members for the sediment concentration in the water, ultimately to try to get at some quantification for how much sediment is being held in these different water pixels that we just masked out. So towards that end, we needed to create a few different files, and one of them was a wavelength file. Let me sort of pull this up just so you can see what this looks like. Very easy, right? I just made this a notepad. It's a text file. These are the wavelengths of interest, and then we were also asked to eyeball from the graph the reflectance spectra for the light sediments, which are all very low values, and for the heavy sediments. So those are just created in Notepad, very, very simple. If you follow along with the lab, what you are to do once you have those guys is to import them into a spectral library. And so if we get over here, spectral library, if I can spell, spectral library builder, right? So we want to import it from an ASCII file, okay. And first we want the wavelength guy, so we just go and find our wavelength guy, which is here, okay, fantastic. And then, so great, we say the wavelength units here are microns, I believe. That's all great. We say OK. And then in the spectral library builder, we want to import those two ASCII files that we created. So from ASCII file, so both the heavy and the light sediments. We want to get those guys in here. I should have done it one at a time. I believe that the first one, let me delete to make sure that I do it right. So I'm going to import ASCII file. This will be heavy, and unfortunately it kills the name, so we're just going to call this heavy. And then I'm going to import the light, so I know. Okay, so this is the light. Enter. Fantastic. So now that I've imported those guys, you can just sort of go through the process. And you got them in. So they're in, and then we can options. What can we do here? We can save Spectra as a spectral library file. Is that necessary? Once they're in memory, create a plot, export it as a JPEG, import it. Yep, save it as a spectral library file. So accept all the defaults, and we are going to call it sediments. And we'll say OK. And I already did that before, but it's fine. So it's bringing it up, and here they are, right? So there they are. So we've created these spectral signatures, and we're actually able to use them via linear spectral unmixing. So there's a tool for that, linear. There it is, beautiful, linear spectral unmixing. And so we want the reflectance image as our original input. We want the mask band that we created. Great. And then we want to go along here, and we say OK. And then in the end member collection, right, we want to use the spectral library that we generated. So from the spectral library file, so that's the sediments guy. So we say OK. We want to select all the items, and then we say OK. And then we apply this guy. And then we want to make an output, and I'll call it SB SMA for spectral mixture analysis. And out pops this sort of wild-looking image. And if you take a look at the bands associated with these guys, the first one is for if you did heavy first, that would be heavy, and then light, and then the RMS error. It actually doesn't make a whole lot of sense to look at this as an RGB image. It's really hard to interpret, what those colors are, because what you're seeing there is the combination of the red and the green and the blue. So that's a little bit difficult for me. So if you look at it as a grayscale on an individual band basis, might make more sense. But just for my pixel value down here, if we look up at the SB SMA, and you can see these values. So for the first value, which is for the heavy fraction, it's like 0.19. The value for the light fraction there is actually quite a bit higher. It's 2.42, which it should be between 0 and 1. So the fact that the light fraction is at 2.42 means that we can't really trust that light fraction to really do anything with. And the last value there is the RMS squared error. So as you look around at your different water pixel values, really the point here is that pretty much just look at the heavy fraction. That's the only one that has any meaningful value. And that's the one that you're going to use to actually end up with a quantified estimate of the suspended sediment load in the image by applying some simple band math. So hopefully that one is pretty straightforward, but this should get you going.